Okay, number 1 asks us to factor, so remember that the first rule in factoring is to find a GCF, so I need to find the biggest number that can evenly divide into each of these terms. So it can't be any bigger than my smallest number, which is 3, and I know 3 goes into 9, and I know 3 goes into 36. So first let's pull out a GCF of 3. And now let's look and see if they have any letters that they also have in common. So I see this one has a P, this one has a P, and this one has a P. And so they have at least one P in common. And I see that this term has a Q, this term has 2 Qs, and this term has 1 Q, so they know that they have at least 1 Q in common. And then we're going to divide each term by 3PQ. So 3 goes into 3. I'm just going to put a placeholder there. You don't have to put the 1 because it goes in there one time. And now we need to remember our rules when we are dividing exponents. I've got p to the 3 here, and I've got 1p here. So I'm going to subtract, giving me 3 minus 1, so I've got p squared. And then here I have q1 minus q1, so my q's go away. All right, so next I'm going to say negative 9 divided by 3, which is a negative 3. And my p1 minus p1 makes my p's go away. And q squared minus q1 leaves me with 1q. And 3 goes into 36. 12 times, so we can say plus 12. And I have 1p here and 1p here, so the p's go away. And I have 1q here and 1q here, so the q's also go away. So now I'm left with this trinomial. And I'm just going to clean my answer up a little bit and say that 3pq was my GCF, and p squared minus 3q plus 12. All right, so this one, notice that it has 4 terms. So first we're still going to look for a GCF. I have a 4, an 8, a 3, and a 6. And I know that 4 can't go into 3, 3 can't go into 4, 3 can't go into 8. So it looks like because I have 4 terms here, now I have an opportunity to factor by grouping. So I'm going to group these first 2 terms and these last 2 terms together, and I'm going to pull out a GCF from each of those. So looking at my smallest number here, which is 4, 4 does evenly go into 8, so I can say 4 is my greatest common factor. And I have an A here, but I don't have an A in this term, so therefore they don't have an A in common. And I have a 1B and a 1B, so that one does have a B in common. So I'm going to divide this term right here by 4b. So 4 goes into 4 one time. I'm not going to put it there. And I have an a left over. And if I subtract b1 minus b1, my b's go away. All right, so now let's take a look at this term. 4 goes into 8 2 times. And my b1 and my b1 would also cancel. So that's just leaving me with a plus 2. All right, let's take a look at this one. My smallest number is 3, and 3 does evenly divide into 6, so 3 would be my greatest common factor. And this one doesn't have an A, so I can't say that they have an A in common. So after I divide, 3 divided by 3 is 1. I have to list my A. And then 3 goes into 6 2 times. All right, so notice that I've got 2 of the same terms, a plus 1. And remember that you don't use 2 of those in your answer, you just pull 1 of those out. So a plus 2 is one of my answers. And the second answer comes from combining this and this by adding them together. So the other term is going to be 4b plus 3. So I just added these 2 together, and they're not like terms, so I can't technically add them, so I list them that way. And if I wanted to make sure that this was correct, I would box these 2 terms to see if it equals my original problem. So when factoring 3 terms, first look for a GCF, but I know that there are no numbers there, so therefore they can't have numbers in common with anything else. So this would be an opportunity for you to use the box, get guess and check, slide and divide, whichever way you want to learn it. So I know that the top number here goes in the top of my box here. And the middle term here of -1 goes in the bottom box here. And so now I'm going to find numbers that multiply to 6. So 1 times 6 and 2 times 3, and that's going to be it. But I need those two numbers to also add or to subtract to give me -1. So I'm thinking it's going to be 2 and 3, but I know that one of them has to be negative in order for me to multiply to get a -6. But in order to find out which one of those are supposed to be negative, I need to see which one fulfills the adding and subtracting to get me a -1. So I know if I do -3 plus 2, that's going to equal a -1. So when I am factoring my terms and pulling out my factors, I know that the only way to get m squared is if I multiply an m times an m. And then I'm just going to pop these two terms in for here, and it doesn't matter if you put the -3 first or the +2 first. So I'm just going to say m plus 2 and m minus 3. And that's how you would factor that, and you can always throw those two binomials into your box to check it, see if your answer is correct. Okay, so this one has 3 terms, and looking for a GCF, I know 3 and 7 are prime, so most likely the only thing that they're going to have in common is a 1. So let's remember our box method, and notice this one's a little different in the fact that I have a leading coefficient here. I have a number before my x squared. So when I have that, I need to multiply 3, or the leading coefficient, times the very last number, which is 7. So that goes in the top of my box, 21. And the bottom of my diamond is going to be -22. It's always the middle term. So thinking about my factors of 1 and 21, I can probably stop there. So let's say 1 and 21. So 21 plus 1 would give me a positive 22. So I need to think about what these two numbers need to be in order for them to multiply to give me a positive, but add or subtract to give me a negative. So I know that if I have -1 times -21, then that is going to give me a positive 21, and a -1 plus -21 is going to give me a bigger negative, and that's going to give me the -22. So those are the numbers that I'm going to put into my box. So remember, if you're going to set your box up, your first term goes here, so 3x squared. And I like to put these x's as placeholders because sometimes I forget to put them in there, and then it messes up my GCF. And the last term goes in the bottom right-hand box. So now these two numbers that I found are going to go in my box, and it doesn't matter which order they go in. You can put the -1 up here and the -21 down there. It doesn't matter as long as you remember to keep the negative signs. So now we're going to find GCF for time. So I need to find the GCF once going this way. So the GCF between -1x and 7, the only thing that they have in common is a -1. Now I'm going to find a GCF going this way. I know that 3 goes into 21, so it evenly goes in there, and my GCF can't be any bigger than my smallest number. So I know that my GCF for those two terms are going to be 3, and I also notice that they have one x in common. All right, now I'm going to find a GCF going this way. So 3x squared and -1x, I know that they have at least an x in common. And now I'm going to find a GCF for these two terms, -21x and 7. So my smallest number is 7, so my GCF can't be any bigger than my smallest number, and 7 does equally go into -21. And notice, just like I did here, if we have a negative sign here, we need to make sure that this term is negative. So I'm going to do the same thing here. If I have a negative sign here, this answer is going to be negative, and it's going to be -7, and 7 doesn't have an x included with it, so therefore it can't have an x in common. So here would be one of my answers, 3x minus 1, and here's one of my answers of x minus 7. So I'm just going to rewrite those down here in my solution area, just like you're going to do on your test. And again, remember to keep these negative signs with the answer. Okay, so this one has 3 terms, but the first rule of factoring is to see if there's a GCF. And because I know that all 3 of these terms are even, I know that I can pull a 2 out of each one of those terms. So I can say that it has a GCF of 2. And now look at my letters. This one has n cubed, n squared, and a single n. So I know that they at least have one n in common. So let's go ahead and divide each term. So 2n cubed divided by 2n, 2 goes into 2 one time, and n to the third minus n to the first leaves me with n squared. And I'm going to do the same to this term. 6 divided by 2 is 3, and n squared minus n1 leaves me with a single n. And then I'm going to say 2 will go into negative 36, 18 times. And the n's cancel out because I have 1 here and 1 here, and 1 minus 1 makes it go away. All right, so don't stop there because you will not get full credit because you need to have this completely, fully factored out. So let's use the little x and put our negative 18 here. And the middle term will go in the bottom of my diamond there. So I need to find 2 numbers that multiply to negative 18 that add or subtract to 3. So let's start making a list. 1 times 18, there's no way that 18 and 1 are going to add or subtract to give me 3. So let's keep going. So 2 and 9, that's either going to give me 9 minus 2 is 7 or 9 plus 2 is 11, and that's not what I need either. Okay, we've got 3 and 6. This might work, so let's try 3 and 6. And I know one of them has to be negative in order for me to multiply to this negative 18. Excuse me. And I'm going to look to this, wow, I'm going to look to this bottom term to see which one will give me a positive 3. So I know 6 minus 3 is going to give me a positive 3. So negative 3 and positive 6 are my 2 terms. So I'm just going to pull those out because I know that the only way to FOIL this back out to get n squared is if they both start with n. And I'm going to put one of them here. So n minus 3, n plus 6. And here's a very, very, very big thing that students always forget to do. Remember that we factored out this 2n originally. So that's always part of your answer. So it goes there. And then write the other part of your answer that we found here. So n minus 3 and n plus 6. Okay, so notice this one has 2 terms. And if you are going to look for a GCF, and I don't see anything that they have in common, but I do recognize that 16 is a perfect square, 9 is a perfect square, x times x gives me x squared, and y times y gives me y squared. And I also noticed that this is a subtraction sign. So what this is called is the difference, which means you're subtracting, of perfect squares. So when you see 2 perfect squares that are being subtracted from one another, it's actually a really easy case to factor it out. So you just need to take the square root of 1 and show it with a subtraction sign, and the square root with a positive sign. So the square root of 16x squared is 4x, and the square root of 9y squared is 3y. So taking a look at, we're going to use those exact same terms, 4x and 3y. So 4x minus 3y, 4x plus 3y, and the only difference in those 2 answers is my change of sign here.